Hello, my name is Juan Felix Rodriguez. I am professor from the University of Brazil in Brazil, and I'm going to talk to you about our project. It's centrifuge modeling for the investigation of the load transfer mechanism of Rigid Inclusion Foundation. This project was done with the collaboration of Professor Bernardo Caicedo of the University of Los Andes, Colombia, and it's part of the PhD project of the student Julian Asdrubal Buritica Garcia. I want to thank to the organization committee for this invitation. Commonly, rigid inclusions are employed for the reforms of the foundation of embankments projects. These embankments are commonly formed by granular soils, and they are reinforced by geosynthetics. Nowadays, this type of foundation it's also employed for the reforms of many kinds of structures. One of the first examples of this application of inclusions was the Rion Bridge in Greece. This bridge has very huge footings of 90 meters diameter, and they were reinforced by 200 metric metallic inclusions of 30 meters length and 2 meters in diameter. Another huge project, and one of the first projects of this application also, was a house estate in Mexico City. Was 74 attached buildings reinforced by a total of 4,391 rigid inclusions of 19 meters length and 40 centimeters in diameter. More recently, and a very large project of liquefied natural gas tanks. Each tank has 96 meters diameter, and the foundation was reinforced by 1,128 rigid inclusions with a diameter of 80 centimeters, and 22 meters in length. The load transfer mechanism of rigid inclusions is very complex. The footing of the raft of the rigid slab transferred the building of the structural load to a load transfer platform, and this load transfer platform transmit the load to the inclusions caps. Some of these loads goes to the reinforced soil and also is transmitted to the inclusions shaft by negative skin friction. Then the reaction of the soil is with the positive skin friction and the tipped load. This research is focusing, this part of the research focusing in this part, in the interaction between the footing or the raft, between the soil transfer platform and the inclusion caps. Some models done by Chevalier et al. Shows that the behavior of inclusions of the load transfer platform when a rigid slab is inclusive instead of an embankment, it's very different. Also, they demonstrate that the efficiency of the system increases a lot when a rigid slab is included. Then the objective of this work is to investigate the load transfer mechanism developed in the earth platform confronted by fine-grained soils with and without cement, characteristic of the central Brazilian plateau, considering the load applied through a rigid slab. Then the contribution are these the mainly contribution, considering a fine-grained soil with compacted with and without cement, and a rigid slab. This soil that we are using, the compacted soil, it's basically a sandy, low plasticity sandy clay. It's a tropical soil classified as a lateritic clay. We determine the shear resistance of this soil with the peak strength resistance and the residual strength resistance. The centrifuge modeling that the centrifuge equipment that we use was the equipment of the University of Los Andes. It's a beam centrifuge with a turning radius of 1.9 meter, maximum gravity field of 200 Gs, and a maximum model weight of 400 kilograms. Here we are going to see the centrifuge at an acceleration of 5 Gs, very slow. And here we can see the centrifugal acceleration of 80 Gs. The model conception is this, the prototype. We have a footing or a rough foundation. Then we have the compacted soil. We have the reinforced soil. That can be a collapsed soil or a subsoil. And here we have the inclusions. The model was simplified by a circular footing or a circular raft with an hexagonal distribution of the inclusions. Here are the model. The footing or raft were substituted by the plate, a rigid plate. Here is the compacted soil. And the collapsed soil or the subsoil, the reinforced soil was substituted by a mobile plate here in the bottom. And we only simulate the tips, the caps of the inclusions. Here is the model, the instrumentation. We can see that we put load cells in five inclusions. We put another load cell in the lower plate. We used also LVDT transducer to measure the settlements of the upper plate. This is the model setup. The modeling was done in two phases. Basically, this is the initial phase when the compacted soil was placed in the model on the top of the plate and the inclusion caps. The first phase, the bottom plate was gradually removed, and a second phase that an external load was applied after the bottom plate was totally removed. Here is the preparation of the soil. Here is the soil mixture with cement, the soil compaction with static load. Here is the model, the compacted soil. Then we put a confinement ring. Then we would do the experimental setup, the modeling, and the end we did a soil inspection, the tiled soil inspection. This is the experimental program. The main parameters we changed was the diameter of the inclusion. We use inclusion of 38 and 76 centimeters. The spacement was constant, and the height of the compacted soil was from approximately 1 meter to 1.7 meters. Here are some of the results. Here are the results from the load cells. Here is from the initial phase, the phase 1 and phase 2. Here we can see the load development at the lower plate, and here we can see the total load development at the rigid inclusions. And here we can see the application of the external load. We can see also then in the second phase, practically the inclusions take all the load that was applied. Here are all the other results. We can see here the load development in the central inclusion, and here are the load development in the border inclusions. The inspection was very important. We can see in the inspection the symmetry, the form of the load transfer mechanism. In plant, we can see also the distribution of the loads, the development of cracks, and we determined the inclination of the load transfer cone, a truncated cone that form in the heads of the inclusions. The ongoing research, we are doing also a real scale instrumented with an inclusion system in the experimental field of the university. We are doing also a rigid inclusion instrumentation of the foundation of grain soils. And that's it. And that's what I want to talk to you about. And thank you very much for your attention.